And Alfonso can see this.
Yeah.
Okay, let's just start here. Okay, I think this is okay. Can you hear him?
Alfonso, can you hear us right now?
Sorry, I had my microphone mute when I was drinking. Sorry, and I forgot to unmute it. So yeah, that looks perfectly fine. So severity is a variable that only applies to patients, right? And that's why you're encoding as missing anything that has to do with controls. Make sense?
Right, right. And so I just have one column for group instead of having two separate columns for control.
That looks perfectly fine. Okay, so yeah, that looks. I'm assuming that the tabs. There was. I remember that Jason mentioned this issue with the, or Saul mentioned. I don't recall that with the tabs being converted to spaces by MATLAB sometimes. So as long as that hasn't happened, can you type the command in that same folder? If you type the command con_load text file, then participants.csv, just to see.
Text file.
Is load text file all together without anything.
Load text file. Like this.
Yeah, text file. Yeah, and then the name of the file, which is participants tsv. Oh, no, not load text file. Why is not? Oh, could you just run FL init at the beginning, just also because it might be that the con path is not yet in there.
Oh, I need to add the path. Okay.
Oh.
Okay. So just do the path is already there, the FL. So just add instead of doing that, what I typically do is do FL init, and the initialization of the FrankLab actually adds all of the paths that you will need, basically. Yeah, that. And it also checks for consistency that the paths are yeah, exactly this type of things. It tells you whether there are any errors or weird issues with your configuration to worry about. And the thing that is warning in there is the mask. So when you create a mask, it's probably going to create it without group permission issues, like a right for the group is typically set to off. So basically you can change that in your Linux system. And anyway, don't worry about it right now. Okay, so try again that, exactly that. Load text file. Yeah, it seems to read just fine. Let me take over just 1 second to quick request remote control. Okay, so I think let me see if I can. No, not yet. Oh, come on.
It's not letting you type at all.
Yeah, for some reason. Let me try again. Yeah, there it goes. So I don't know why it's not. Okay, so just to make sure that this looks fine on IOScript. Yeah, that's fine. And severity, it has missing values, and the other one was participant ID, which, okay, that looks perfect. Yeah. So this is just like a quick check to make sure that even to the file that looks fine. So it looks fine to the eye, but basically if con can't read it, then you know that it's going to be accepted by the FL scripts without a problem. Okay, so
and I might want to consider adding another field entitled valid, like we discussed yesterday, if I want to exclude any particular subject from the analysis, and I'll just type it like whatever is.
Yeah.
Okay, then. Okay, so this is just the speech minus baseline for the whole data set. So all subjects. And then, so I had run this before, but I didn't include severity. But then when I had severity, it wouldn't run.
Huh.
But that was like a few days ago, so I don't know.
Let's give it a try. And the only thing is that in the current versions, you don't need to actually specify subjects in there. So you can just delete the subjects something like, because by default, it's going to assume that you're going to enter all of the subjects.
Okay.
You use the whole field.
Oh, just the whole field. Oh.
Yeah, just remove those. Yeah, exactly. Perfect. And also, this is going to work just fine, but without I was mentioning this before. Since we talked yesterday, I also changed the name. So instead of conditions, you can use now contrast names. You can still use conditions for backwards compatibility, so it's going to work fine. But in the future scripts, if you want to use contrast underscore names, that's kind of like the new name for that field. And yeah, that looks perfectly fine. That should work. Okay, so let's give that a try if you want.
So I'm going to look at, so severity will be included in the model.
Right, so that will be a design matrix with two columns. One will be all ones containing the all subjects, basically a constant term of your regression, and the second will be the actual severity values. And because the subjects that are controls don't have any severity values, they are encoded as missing, they will be basically removed from the analysis. So basically you are doing a correlation between functional activation and speech minus baseline versus severity within patients only.
Wait, no.
Does it sound right?
You only have you include severity, so you can include subjects that have a severity measure. So
Okay.
if you just want to do speech minus baseline, you wouldn't include severity here. But if you want to look at the correlation between the activation and severity, then that includes severity.
Okay, so I don't think that makes sense for this contrast. Okay.
Okay, so if you change that and you only have all subjects in the design, you still need to change the contrast to only have one value, so basically just once. Or you can, in those cases where you have only one column in your design matrix, you can remove entirely the contrast underscore between. It will be taken by default to be just one.
Okay.
So in this particular case where you're just doing like a one sample t-test, so this analysis will be a one sample t-test of the speech minus baseline. So you're looking at the average of the speech minus baseline effect across all of the subjects, including both patients and controls. Is that right? Is that what you wanted there?
Yeah.
Okay, so in that particular case, you can actually remove all of the lines that say contrast between one, contrast within one, because that's kind of like the default thing that will happen anyway.
Okay, so...
But you can leave it there as well. I mean, it doesn't change anything. I'm just saying.
So if I just want to look, like, if I just want to examine if this contrast in activation is characteristic at the population level for all speakers, both stuttering and non-stuttering alike, I don't include severity. But then if I just want to look and see, is this contrast activation attested at the group level for stuttering speakers, then I include severity, and it will only do it for the stuttering speakers.
So this is looking at
That particular
correlation between severity and the activation.
Right.
If you want to include it as like a nuisance regressor, then you would switch the 1 and the 0, and you would only want to look at it as stuttering.
So maybe I don't need this for these contrasts. Maybe like... It's just like not really clear to me, like at what...
You want to maybe just describe, just in a couple of sentences, how the different conditions are in the study, and then your questions, what are your questions, and then we can talk about, how you would set up your second level analyses to address those questions.
Sure. Okay. So it's, you are all familiar with the motor sequence learning paradigm that we're using. Here we want to examine the bold contrast for the illegal novel and the illegal learned, and then for the illegal learned versus the legal learned. And we're basically looking to see if various nodes in the working memory network are activated to a greater or lesser extent as a function of the particular sequences that they're producing, right?
Perfect. And do you want that?
Like I envision that we would do both of these contrasts overall for all subjects, and then examine each individual patient and control group separately.
Okay, that makes perfect sense. And so without any reference to severity, we'll get to severity later. So from your description, basically what you want to look is just look at this contrast, basically the difference between novel and and learned an average basically that across all of the subjects just to look at which regions show differential activation in novel condition versus learned condition. So you just computing the average across all of the subjects will tell you that basically aggregated across all subjects disregarding whether they are patients or controls. And then as you can say, as you were saying, you want to look at that same thing separately for the two groups and do a comparison between the two groups to actually tell. Because when you look at the one group and then the other, there are going to be some difference between those results that are just spurious, and you want to know which ones of those differences are actually significant or not. So for that, you actually run something like a two-sample t-test where you compare the difference in novel versus learned in one group versus the other. Is there an accurate description of what you want to do?
Yes.
Okay, so to do the first one is exactly what you have now. So to do just the average difference between novel and learned conditions across all subjects is exactly this design. So you are just entering one condition, one regressor in your design matrix that has all ones to tell the model basically that you just want to look at the average across all of the subjects. So this will already give you basically those regions that show differential activation, if any, across those two conditions across all of the subjects. And then if you want to look at the difference between, so basically the same thing, but how is it different in one group versus the other, what you could do is just add how was it called, the other covariate, the covariate that describes your different groups.
It's just called group, yeah.
Group. So, okay, so just add the group as a second thing in your design. So you have all subjects and you also have group identity as a second effect that you are modeling. And then the contrast between, which has to have two numbers now, instead of being just a 1, it's a 0, 1 to look at the difference between the two groups. And that would be a two-sample t-test, basically looking at the activation of the two. Sorry, go ahead.
So how do I know it's not analyzing each group separately versus comparing the two groups directly? Does that make sense? Because when I looked at this, I thought this would compare the two groups to one another.
Right, that's what it does actually.
Separately. Is that what it's doing?
So I think what you want to do is first look at, are there group differences? So think about it in your...
But that's what this is doing.
Right. And that's what you want to do as a first step. And then because if there's no group differences, you don't want to look at them separately, right? Because then they're basically the same. It's kind of like if you do an ANOVA and then you do some post hoc, pairwise comparisons to, so you look at the main effect and then you go in further if there is reason to do post hoc analyses. So then it will be, if there are differences, and Alfonso, you can correct me if I'm...
No, you are saying everything correctly, so that, yeah, go ahead.
Then if you find group differences, then it may be interesting to pull them apart and then
look.
Okay.
Okay.
But even this will give you the contrast between the differences anyway. So because there's only two groups, you wouldn't actually need to do a follow-up analysis, right?
Well, you would typically do it just to see where you're going to get like a positive number where the activation is greater in the second group compared to the first, but you're not going to know whether the activation was actually positive activation or negative inhibition, like a negative activation. So it's always a good idea to actually, in any regions that may come up in this particular analysis, to do post-hoc analysis looking at the actual activation within the two groups, and going to make sense that you're interpreting those correctly.
Okay, that makes sense.
Then you can also do like additional analysis for you have that, and this is where severity may come in. I mean, you might say, well, perhaps the difference between the two groups is actually correlated with severity, and you might want to look at whether within that region you have any correlation between the activation, the response to the activation, and severity of the illness, or you might actually try to control for that difference, controlling by severity. I don't know. Is there any reasonable, like, 0 level of the severity covariate that might be the most, that would indicate that a patient is as similar as to a control as possible, at least kind of like theoretically?
I don't know if I'd be SSI.
Well, yeah, so there's a question of whether, so SSI would probably just be like the average one. Or wait, that would be equivalent to a control. So I think
the most fluent end of the scale.
I think it's the most fluent end is like 4 as a score. I don't know. There's just some weird thing where it just doesn't actually end in 0. I don't know if that's like I don't know if you want to look at what's the difference between stuttering and non-stuttering participants for the least stutter, like for. I don't know if that's a question.
I mean, that's like I'm just saying not for this particular study, but in general, that's one thing that you might want to do with this type of covariates. You might have a covariate that you want to just control for it, and you want to say, well, I want to compare the groups, the patients and controls, but I want to discount any difference that may be just be caused by the severity itself. So I want to compare whether there are any intrinsic difference beyond those that I'm observing by these variables. So I mean, it might not be that appropriate for severity, but let's say that you have some secondary symptoms in this same condition, like some, I don't know, memory problems, and you want to discount potential difference between the controls and groups in memory problems and only address this other kind of like conceptual module that is problematic in your patients and is okay in the controls, but it's beyond these memory issues that might also correlate, just because they are the patients tend to have also higher memory problems. So you have this memory load or something like that covariate, and you want to control for that in the comparison. And you want to say, well, I want to look at the difference between controls and patients, but discounting anything that can be better explained by difference in memory problems within the patient population compared to controls. So that's a typical scenario where you would add this severity in this case, or some other covariate that indicates the thing that you want to control for as something that is so basically an ANCOVA type of analysis. Where if you do an ANOVA, you are comparing two groups, but you want to control for this third covariate that you don't care about, and you want to disregard those effects. In this case, it probably doesn't make that much difference because the severity index is the thing that actually is most related to the issue at hand in your patients, right? So if you're looking at the study in the severity, I imagine, I'm not totally sure if I recall the details of your variables here.
Just to interrupt you for 1 second, I just realized I started the session on my account instead of Bobby's, so it's going to time us out. So I'm just going to quit this session and then resend a link via Bobby, just so we can stay on for longer.
No problem.
And can you send the link via GChat, because to go through the VGN, the BU email?
Right. Yeah.
I only got it at like 9:15.
Oh. Okay. Yeah, I'll just GChat it.
Thank you.